how we set up and program this laptop stand, well, make sure you stick around. So to get started, what we're going to do is we're going to walk through laying down the laptop stand, getting it ready to cut and making sure that there's plenty of margin around the outside of the stand and the individual parts themselves before we get that ready. And then what we'll do is we'll jump into CAM and we'll talk about the different kinds of toolpaths we're using and how we're utilising those toolpaths to get the best finish possible. So as you can see, the laptop stand is all assembled here, so it was designed in place to make that visualization of what we were trying to achieve a whole lot easier. So what I'm going to do to start with is I'm actually just going to draw a brand new component. That brand new component is basically going to be laid down flat. That new component is going to be the raw material, the board that this laptop stand is going to get placed inside. That's going to make placing these parts really, really easy. So let's get started with that. So I'm just going to jump into Create and I'm just going to hit New Component. I'm just going to rename that and I'm going to call that Raw Stock. And making sure it's active and then press OK. Cool. Now from here what I'm going to do is I'm just going to come up to Create and I'm going to go to Sketch. Now I'm just going to come down and I'm going to select a sketch plane, which is just going to be my base plane. Looking top down. Now our sketch tools have just shown up. So I'm just going to grab a 2-point rectangle. Just going to click that once. Come down and I'm just going to snap to the red line, just anywhere. I'm just going to drag out. Now I'm just going to come in and dimension. Now remember, you can come down to Create and you can go down the bottom and click the sketch dimension. Whenever something has got a capital letter next to it, you do have the ability to use hotkeys. So you can hit D on the keyboard. So if I hit Escape and I go out of that, if I hit D on the keyboard now and I come down and select any of these lines, I can now dimension that line. So to start with, I'm going to make it 500. And I know the material is 600 high. Cool. Now all I'm going to do is I'm just going to dimension the corner of this rectangle just from the center of my working plane there. You don't have to do this, but it's just something that I like to do just to get everything in place to start with. Escape on the keyboard, finish sketch. There we go. So now we've got our laptop stand. It's still looking invisible, and that's because our raw stock is currently active. So our raw stock, which is the sketch here, is the current active component. It's not yet a component, but it is a sketch inside of a future component. So what I'm going to do here is I'm just going to hit E on the keyboard, and I'm just going to extrude this. Now I know the material that I'm using is 18mm pine. It's an 18mm pine that is pressed together, a whole lot of little pine strips that are pressed together and glued. So I'm just going to make this 18mm, and the operation type is just going to be new body. Cool, that's looking pretty good. Now I'm just going to come up the top here and I'm just going to reactivate this component. Now what we're going to want to do is we're going to want to place the individual parts inside this raw stock. And we want to create copies of all those parts, copies that are driven by the original design. So if the original design was to change for any reason, I was to change the dimensions of it, I was to make any little tweaks, change the logo of it, the actual design will change as well. So the way to do that is to come up to the original design, laptop stand, select the drop down, To start with, I'm just going to lay down the top. So I'm just going to go down to the top here. I'm going to hit right click and I'm going to go down to copy. Then I'm just going to hit paste. Now what paste is going to do is it's going to paste a direct copy of that original version. Now, what I mean by direct copy is that's going to allow it to be edited later on, so it's going to be driven by the original copy or the original version. So I'm just going to hit paste. Snap to the top plane, drag it over. Cool, looks about right where I want it. I don't need to get too precise with this. Again, I can visually see that there's plenty of margin around the part. Cool, that's looking pretty good. Then I'm going to press OK. Now, what I'm going to do is I need to flatten this out. Now, there's lots of different ways that I can do that. I could manually rotate the part around, but the way that I choose to do it is I'm going to come up to Assemble. I'm going to create a joint. Now, what I'm going to do is I'm going to select just one of the flat parts of this first part. So I'll select this part, and then I'm going to come down to my raw stock, and I'm just going to select the center of it here. Now, what that's going to do, as you can see, is it's just laid my part down. So now I'm not having to worry about making sure that I angle it or rotate it around a selected angle, or making sure I get that angle correct. I don't actually care about the angle at the end of the day. My main goal here is to lay it down flat, ready to cut it. Cool. So from here, what I'm going to do, it's going to come up, it's going to drag the part up, and drag it across here till about the center of the board, roughly where I want it to be, ready for machining or cutting. And then I'm just going to press OK. Cool. Now, one thing you can see is I haven't laid my parts down inside my board. That is one thing you can do. You can lay the parts down inside the board and use that as a stock reference. And we'll go through and do that shortly. Next thing that I'm going to do is I'm just going to come up and I'm going to grab this leg here. Again, I'm just going to hit copy. And I'm just going to hit paste. Jumping around to the top view again. Dragging it out. Rotate it around. And I'll just angle it to roughly the right angle. And I'll just select OK. Now again, exact same thing. I'm just going to come back up to joint. I'm just going to create another joint. That one again, I'm just going to come around and I'm going to select a flat part of this. Cool. Rotate back around again. Using the shift on my keyboard and the center mouse button to orbit around my workspace. Cool. I'll just select the center again. That will snap it flat. Everything's looking good there. And I will drag that down into position. So I'm just going to drag that down the bottom there. And I'll put the other one in this space here. I'm going to press OK. Cool. Now the last leg, again, same thing. Let's come up the top here and I'll select that leg. I'll press copy. Come down and hit paste. Drag it out. Rotate it around in the opposite direction, so it's roughly in place where I want it to be. Let's turn that around. That, and let's hit OK. Come back up to joint. Come down and select the bottom of the part. Come around again, and I'm going to snap it to my raw stock. There we go. Snapping to the top, and we're just going to drag it into a position. Cool, that's looking pretty good. We've definitely left a lot more margin around the top of the part and in between the parts than what we need, but there's no harm in doing that. If the stock is not going to be able to be used for really anything else, then you're probably better off leaving a little bit more space than otherwise you would normally do between the parts. But if you are wanting to use the stock in future, it's just something to bear in mind is am I going to reuse this later on? Do I need tight margins, or am I better off keeping a bigger gap? Especially in wood, if you cut too smaller or leave too smaller margins between parts, one thing that'll happen is tear out, where those little margins will actually tear out. And if you've left tabs to try and hold the part in, the parts are more likely to fly out or come out because those little margins have ripped out. And I've seen it many times where people leave these tiny little margins and put tabs on there, and unfortunately it's just not strong enough. So it's just something we do need to bear in mind when we're doing this. Cool, and I'll just come in here and press OK again. So we've got our 3 parts there laid out. It looks pretty good. And again, they are a direct copy of this. Now, what I mean by that, and I'll just do a quick demonstration of how that works. So what I'm going to do is I'm going to delete this inside fillet here. And we'll just look, this is the same fillet that's on this side. And I'll come over and show you what happens. If I come over here and I'll select this fillet, we'll just keep an eye on this other side. I'll just hit delete. And you'll see that it's deleted on this opposing side here as well. So what that means now is, because it is a direct paste of this version, I can make changes to this version and it'll update on the stock here. So what that's going to mean for us moving forward is any changes, if we wish to get rid of the logo and put a new logo on it, or we want to make slight changes to the size of these little slots, again, those changes are going to follow it through, right through to cam as well. Now with cam, we will probably have to regenerate or maybe reset up a toolpath when we do that, but again, it's just going to make the whole process a little bit faster and easier for us. So just hit Control-Z on the keyboard and we'll get rid of that. Control-Z or hitting the back button is your best friend. It gives you the option to go backwards and undo whatever you've done, just like you would if you're using any other program. Cool. So the last thing we need to do before we jump into cam is to move our stock into place. So the way that I'm going to do that is I'm just going to come up into joints, and I'm just going to suppress all of our joints. Hit suppress, suppress, suppress. We could just come in and edit these joints and move the part into position, but we don't really need the joints at the end of the day. The full purpose of using them was to make sure the parts are flat in place. So I'm just going to come down, just going to click on this raw stock, and I'm just going to drag that up 18 millimeters. There we go. So now the parts are actually inside that raw stock, so we can use that raw stock as our reference. The first thing that I'm going to do here is I'm just going to jump up into the top toolbar, and I'm just going to do a setup. Now that setup's going to allow me to select what is my stock, how big is my stock, how high is my stock, and it's also going to allow me to select where am I going to zero my machine out, what is my datum or my origin. So I'll just come up and do that here. Hitting the setup button. Now you can see it's highlighted everything here, which we don't want it to do. I'm just going to come down to model, and I'm just going to come and select the individual components that I want to be included, which is these here. Cool. Before I do my work coordinate setup, I'm just going to jump over into stock. I'm going to go to mode, and I'm just going to go down to from solid. Now the solid that I'm going to use is just going to be this blue box. Then I'll jump back into my setup. I'll select my orientation mode, so I'm going to use select Z-axis, plane, and X-axis. First thing it's asking me is to select the top of my part, so I'll just go through and do that. Selecting my X-axis, well, the X-axis is going to run across this line. Remembering you don't have to use a line as the reference for the X-axis. You can utilize a face for it to point towards, so I could select this face and you'll see the X-axis will snap around to that face. But I prefer to use the line as my reference, or an edge as my reference. Come down and select my stock box point. Now, on a lot of routers, we like to zero the machine out on the front left-hand corner, and that's because routers generally are quite large and you are standing at the front of them, so you're not having to lean all the way to the very back, especially when you're manually zeroing everything out. It's all well and relative and in view for you. Select this bottom left-hand corner and hit OK. So before we get into creating toolpaths, this is a great opportunity to talk about our sponsor today, which is ChipX. ChipX are a great bunch of guys that have set up this little company down here in New Zealand, and they supply some really high-end tooling and high-end work holding solutions. They've also very kindly set up a small range of tooling that work really well with our machines. One thing that you should know about our machines is we do use Makita routers, and down here in New Zealand we use the metric system, and a lot of people don't quite understand imperial. So the routers themselves, they are a 1/4 inch collet. So we used to get a lot of requests from people to supply tooling that was metric. So the way we got around doing that is basically making tools that are ground down. So it's a 1/4 inch shank, and they go down to being a 6mm tool or a 3mm tool. So make sure you guys check them out, and ask any questions if you have any questions, because they are really helpful. Cool. So to start with, we're going to come in and we're going to create our first toolpath. The first toolpath that I'm going to use for this is, you'll notice that we've got a lot of little parts here that we're going to need to cut out. So there's a few ways we can go about doing that. We could use a 2D contour and go around and individually cut each part out. But the way that I prefer to do this is work smarter, not harder. So I'm just going to come up to 3D, and I'm going to use a 3D pocket to get rid of all that internal material here. So I'll select 3D pocket. I'm going to come over here and I'm going to select my tool as tool. Now, you can see here I've actually downloaded the ChipX tooling library. So ChipX have an awesome little tool library that you can utilize, and you can actually import it directly into Fusion360 for all the tools that they do stock. So I'll come in here and select the tool that I've already set up. Let's press OK. Now, the first thing that I need to do is I just need to jump into geometry. Now, I want to create some boundaries for this. If I was to just come and press OK at this point, the tool's going to come in and it's going to try and cut away all of that raw stock, both internally and externally around the outside of the parts. Now, that's something that's going to take a really long time. So what I'm going to do here is I'm going to right-click back on this toolpath here, hit Edit, come back up to Geometry. Under Machining Boundary, I'm going to go down to Selection, and I'm going to select the outside of all of these parts, so that way it's only going to cut the internals. So I'm just going to select the outside of this one, outside of this one, and outside of this one. Changing my tool containment to Tool Inside Boundary. Now, being that it's Tool Center on Boundary, that's probably not going to matter, but I like to think ahead and think about what I'm actually doing and make sure that I am purposeful in all the settings that I input. Then I'll come here and press OK. We'll see what will happen now. It's looking a bit better. Some very small step downs there. So we'll just come up, and we'll just right click on that toolpath, and we will jump over now to our passes tab. Now, what we're going to do in our passes tab is we're going to change our maximum roughing step down. Now, I know that the router is fully capable of cutting around sort of 5 to 8mm per pass in this kind of material, but I want to get a reasonably nice finish, so I'm going to reduce that down to 5mm per pass. Now, it's wood. We're going to do a little bit of sanding to give it a bit of a clean up, so I'm going to turn off stock to leave for this. And I'm going to hit OK. This is starting to look pretty good. Now, one thing you can see is we've got some massive helicals here. They're really a low pitch helical. Now, we are cutting wood and we're using a single flute cutter. So for what we're doing here, we can probably jump back in again, edit, come back into our linking tab, and we can change our ramp angle. So I'm just going to increase that ramp angle to 15 degrees. Now, the last thing that we're going to want to do is we're going to want to cut through the part slightly a little bit, because material is never what it says it is. So this, I know this is 18mm pine, but it's probably 18.2 mils to be honest, and I don't want to surface it. I just want to keep it as raw as possible, but I do want to get a nice bottom edge finish. So the way that I'm going to do that is I'm going to cut through by probably 1 millimeter below the bottom surface. So the way I'm going to go about doing that is right-clicking again back on that toolpath, hitting edit, and I'm going to jump into my heights tab. Now, currently my bottom height is set up to be from model bottom. Now, what I can do from this point is I can actually come in here and I can just hit -1 and press OK. Now, what that's going to do, again, if I rotate around the side of my part, zoom up, you'll see that it's actually cut through the part by 1 millimeter. Now, 1 millimeter is a huge amount, but for cutting timber, it's actually not, because I am going to run a wasteboard underneath the material, and I do want to get a nice surface finish on the bottom edge, and the tip of the cutter to get a nice surface finish on the bottom edge is not always the best place to gain that. So by cutting that little bit deeper, we are going to try and reduce some chipping, and we're going to try and get a little bit better finish. So the next toolpath that we're going to do is we're going to do a 2D contour to cut these parts out. I'm going to do two 2D contours. The first one is it's going to leave a little bit of stock and it's going to ramp down into the material. The second contour that I'm going to do is going to plunge down and it's going to remove that last little bit, and it's going to get rid of those little witness marks from those multiple depths when I first cut the part out. That's going to gain me a little bit more accuracy on the part. Not that it's going to matter hugely for what we're creating, but it's still good practice and a good habit to get into. So I'm just going to come up to 2D here. I'm going to hit 2D contour. Again, because I've previously used the same tool, it's already pre-populated the tool or the tool selection with what I've previously used. So just something to bear in mind, and those same feeds and speeds that you've already populated the first toolpath with will follow you all the way through. Now, I'm not going to get too much into feeds and speeds today because that is very much related more to what brand router you have or what you're using to cut this out with. Make sure you stay tuned. In a future video we'll definitely have some more information on feeds and speeds and selecting the right feeds and speeds for your router. It's going to come down the bottom here. I'm going to select this bottom edge. That's the edge we're going to cut down to. Again, I'm just going to come around all of these parts and do the exact same thing. Cool. Now hit OK. Cool, that's all looking pretty good. Now, one thing we do need to be careful of is what way the arrow is selected. So if I go back into geometry now, and I jump into this part here and I flick the arrow around the other way, you'll see the arrow actually looks like it's now inside the part. So if I was to come and press OK now, you'll see that it looks like down here, the tool is actually plunging down inside the part. So this is a really common problem, and I see it coming up quite a lot in questions, is why is it trying to cut the internal side of my part out? Well, it's the direction of the arrow. So make sure you jump back in again, go over to geometry, and just click the arrow. That'll jump it to the other side of the line. Cool. Now the next thing we're going to do is we're just going to come into our passes tab and we're going to do multiple depths. So for this, again, I'm going to cut about 5 millimeters per pass, and I'm going to come into my linking tab and I'm going to do a ramp. I'm going to ramp down into the material with a 10-degree ramp. Now, how do you select your ramp angle? That's a really good question, and that comes back again to trial and error. There are some really good calculators out there that will give you a rough estimate of what that ramp angle should be, but in timber it's pretty forgiving, so don't get too carried away with making sure that you calculate that out properly. Come back in and just press OK. That's looking pretty good now. Quite a steep ramp angle. We could probably reduce that, and that's going to put a little bit less load on the cutter when it first enters the material. But again, from experience, I know that that ramp angle is going to work for this material, and we're not going to get too much chatter or noise or the cutter breaking. So let's come in and hit edit again. The last thing that we're going to want to do is to Again, we want to cut a little bit deeper than the part to make sure that we do cut it out, because again, the bed of the machine could have a slight camber on it, or could have a hump in the middle of it, or the material could be a little bit thicker than what we thought it was. So what I'll come and do is I'll change my bottom height, and I'm just going to put a negative offset of 1mm there again, or 0.5 is usually pretty good, but 1mm for argument's sake for this. Now our toolpath is looking pretty good. Let's get into creating some tabs to make sure that our parts aren't going to fly out. Just going to go to geometry and go down to tabs. Tab shape is the first thing. Now, I prefer to create rectangular tabs. Again, it's a good practice to get into. End mills are really not designed to plunge, so having a triangular tab, it allows the cutter to re-ramp down into the material again. So I'll just change it to triangular. Tab width, 6mm is pretty good. Tab height. Now, when we're factoring in tab height, we need to think about, have we got a negative offset, and are we going a little bit deeper than the part itself? Because if I was to just come in here and press OK now, and zoom up on one of these tabs, we'll see that our tab is actually starting lower. Yeah, I'll rotate around a little bit so we can see that a bit better. There we go. So our tab is actually starting lower than the part. So this is a really common problem where you have tabs flying out or tabs breaking, is you need to factor in and increase your tab height if you are doing a negative offset and cutting down below the part. This is going to prevent the tabs from breaking out too soon, basically. So I'll come back in and edit that toolpath, come back into geometry and go down to my tab height. Now, I know that I'm going negative 1mm underneath, and you can see the little tab triangles there. So what I'm going to do is I'm going to go, well, I want my tab height to be 1.5 plus 1. And that's going to bring those tabs up another 1mm. There's still going to be a little remnants of a tab down inside the wasteboard or down a little bit lower, but the point here is to make sure that the tabs are actually holding the part in. Now I'm just going to change my tab positioning. We've got by distance and we've got at point. I prefer to use at point because there are times where at distance, by distance, doesn't work that well, especially on curved surfaces or on angles. Come in here and I'm just going to roughly select some points where I think that I need tabs. Now this is very much a trial and error thing as to how many tabs you need, and different materials are going to require different amounts of tabs, and if the tabs are slightly higher or slightly wider, you may not require as many tabs. But you want to keep the cleanup to a minimum, so I like to make bigger tabs and do fewer of them, because then I'm focusing my cleanup on particular areas around the part. Now again, we can actually select the top surface to put the tab. Now, if I come around the back here and I was to select the top surface, you'll see the tab will actually automatically jump to the bottom surface, because the tab is going to display on the toolpath or on the contour that has actually been selected, and because the bottom edge has been selected, the tab is going to jump down to that bottom edge. Remember, not being too precise, but also making sure the tabs you're putting in are not in a really awkward place, not in a position where you can't sand it out. So for instance, I could place a tab inside this piece here, but that'd be pretty pointless, and it would be a hard job trying to clean that up, so I won't for that. Cool, so the final thing we need to do with this toolpath is we just need to come in, right click on it, hit edit, and add some stock to leave. So I'm just going to go down the bottom here, just going to close. Remember, you've got these little arrows here, and this is going to allow you to reduce the size of this menu here, so you can read the menus that are below. Sometimes on a laptop screen or smaller screens, you can get lost in the menus. So just go down to stock to leave. Radial stock to leave is what I care about. So I'm going to leave 0.5mm of radial stock. I'm going to leave 0mm of axial stock. So that basically means that I'm going to leave 0.5mm around the outside of my part, and then I'm going to leave 0mm axially on the bottom of the part. And then I'm just going to come in here and select OK again. That's all looking pretty good. Now, the last thing that I want to do is I just want to come in and I want to duplicate this toolpath. Now, the reason why I want to duplicate it is because if I was to come and create a brand new contour, I'll have to try and get those tabs in exactly the same place, and that's nearly impossible. So the best way to make sure the tabs are always in the same place when you're trying to cut or finish an existing surface is actually to right-click on that existing toolpath and come down to duplicate. Cool, that's just created two versions of the exact same toolpath. I'm just going to rename this one so I know what it is. I'm just going to call this Finish. Right click on this toolpath, hit Edit. First thing we're going to do is just going to go up to the Passes tab and I'm going to turn off Stock to Leave, and I'm going to turn off Multiple Depths. And I'm going to jump into my linking tab and just make sure that my maximum step down is more than the material thickness. Otherwise it will contour down to that level and then it will go all the way around the part again and contour down again to that level. So being that it's 12 millimeters and the stock is 18 millimeters thick, it means it'll go around the part twice, if not 3 times, to do a finishing pass. So let's increase that to 20 millimeters. The other option is I could just turn off my ramp. So I will do that for this. I'll just turn off ramp and then I'll press OK. Cool. That's looking pretty good there. Now, the one thing that's going to happen is my tool is actually going to plunge down into the material and then it's going to bite, because remember, there is still stock sitting on the outside of that part. Now, for this, it's probably okay, but this is where turning that ramp back on for doing this, or the other thing we can do is we can change our lead-ins or our transitions. So what have we covered today? We've gone through setting up the part, getting ready to machine it. We've gone through creating a pocketing toolpath and pocketing the part out and leaving no stock. We could come in and create a second pocketing toolpath, or we could do a 3D horizontal to clean up the surfaces on the part, and then we've created a roughing toolpath to clean up or cut the outside of the part out, and then a finishing toolpath to get rid of those little witness marks from the multiple step downs. And that's going to allow us to tolerance that part or to get a better finish on the outside of that part. The last thing that we're going to need to do here is we're just going to jump up and do a quick simulation, and then it's going through to post-process it. Going to come up to simulate here. Making sure that I select the whole setup before I simulate, otherwise I'll get lots of collisions. Press OK. Cool. So there is an instant problem there, and that is that my tool holder is going to collide. So that's something that we need to bear in mind, is that if we've got a tool selected and the tool is too short for the part, the simulation is going to recognize all of that. So one thing that I can do is I can come back into the tool itself, and I can edit that tool to make sure that it is going to work for the part, and making sure that when we do edit the tool, we are actually following what the tool is, the length of the tool, the correct length of the tool, the correct diameter of the tool. So I know the flute length on this tool is 20 millimeters. Now I know the shoulder length on the tool is 22 millimeters. Cool. Now if I come in here, press OK again, watch that toolpath reload. Same thing, come into this toolpath, just reload that one. We can right click and regenerate this bottom toolpath as well. Coming in here and just hitting simulate. Cool, that's all looking pretty good. So the last thing to do now is to post-process the toolpath and to send it to the machine. Now, one thing I'd highly recommend is If this is the first time running that program, is post-process just the individual toolpaths by themselves and run them on the machine. That way, if there is any issues or you do need to make any changes, you have the opportunity to do that without having to basically come in and remake the whole thing again. If you guys like these videos, make sure you like and subscribe and click that bell notification. We've got all the links down in the description to everything we've talked about today, so ChipX's website and again, the Fusion model, so make sure you stop by and check it out. If you like these videos and you want us to do more, make sure you put a comment down in the description. We really enjoy making them and we've got a ton more content that we're hoping to create. So, see you next time.